Morning, everyone. Morning, Aviram. Morning, Soumya. Morning, Jashran, Malik, Samya, Shreya. Morning, everyone. Okay, so we'll be starting the class now. Okay, we'll be starting the class now. We won't be waiting for another 10 minutes because students have made this habit of coming late. Okay, okay. So the chapter that we are going to start today is heat, right? Okay, right, everyone? So when you talk about this chapter, okay, because we have studied something about this chapter in our junior classes. Okay, so suppose I want to talk about this chapter. I want to talk about heat, right? So what comes in your mind? Tell me. We have studied this chapter in chemistry also, right? Thermodynamics, if you remember. So if I talk about this chapter, okay, what are the topics that pops up in your mind? Tell me, what are the topics that pops up in your mind? Tell me. Energy flow, okay. Okay, so I'll just write it down. Okay, I'll just write it down. So when we talk about this chapter, heat, or this topic heat, I can say that, okay, this chapter heat is divided into multiple subtopics. Okay, multiple subtopics. Now, when you talk about the first subtopic, so I can say that, okay, when we talk about this chapter, I should know about what is heat, right? Yes, how it is measured, how it is transferred from one body to another body, and all those things. Yes or no? Tell me. Yes. And what are the effects of heat, right? Or the change in temperature in the properties of different objects. This is what we have to study. So when we talk about the topics, the first topic is something called calorimetry. Calorimetry. Okay, and thermal expansion Think about it. When you talk about the second topic, what do you think? The second topic should be related with transfer of this heat energy, right? So I can say that the second topic is basically a heat transfer. Now, what about the third topic? Tell me, what about the third topic? Third topic is something that we have already studied in chemistry. Yes or no? Tell me yes or no. How many of you remember third topic? Tell me. The third topic is, yes, very good. Yes, so third topic is KTG and thermodynamics No, dynamics. So I can say that when we talk about this chapter, when we talk about any problems or any concepts related with heat, I can make these three, tell me these three topics. Okay, I can classify them into these three topics. Now, then these topics will be further divided into different concepts. Okay, so today we are going to cover this first topic, which is calorimetry and thermal expansion. Okay, now when we talk about calorimetry, think about it. Okay, we will start with calorimetry. Now, what do we mean by calorimetry? First of all, we have to ask, okay, do we know what is heat? First of all, do we know what is heat? Right? Second question that we should ask, okay, if we know that it is a kind of energy which is transferred from one object to another object, right? Tell me yes or no. Yes or no. It is an energy which is transferred from one object to another object. Makes sense? So we have, right, we have seen this in our daily life when we talk about a cup of coffee. Okay, when we talk about a cup of coffee, right? Cup of coffee. When it is left at room temperature, then the coffee get cold, right? Coffee gets cold. Yes or no? Tell me, yes or no? So I can say that, okay, heat is transferred or heat is transferred from surrounding, right? Yes or no? Yes or no? Or suppose I'm having hot water, a tub of hot water. We have a tub of hot water. Suppose this is hot water. Okay, hot water. And again, we have a tub of cold water. Cold water. Right? Now, if you connect these two, if you keep them, okay, in contact with each other, what will happen? Tell me. Or if you mix them, what will happen? Tell me, what do you think? Tell me, what do you think? This is very easy. This is something that we have already studied in our junior classes, right? We know this from our intuition that when we talk about these two waters, I can say that there'll be transfer of energy from this to this. Yes or no? Tell me, yes or no? Right? And that transfer of energy is called as heat. Okay, so if I ask you, what is the heat of this? Suppose this is first vessel, this is your second vessel. What is the heat of first vessel? Tell me, what is the heat of first vessel? Can I say that, okay, heat of first vessel is 100 joule and heat of second vessel is 50 joule? Can I say something like that? Tell me, can I say something like that? Yes or no? My question is yes or no. This object is hot, this object is cold, right? So can I say that it will have 100 joule and it will have 50 joule? The heat of this is 100 joule. Heat, I'm saying heat. Heat of this is 100 joule. Heat. And heat of this is 50 joule. Yes or no? Tell me, everyone, please let me know yes or no. My question is, can I say the heat of this object 1 is 100 joule and heat energy of second is 50 joule? Samya, Nishita, Meet, Vivek, everyone, Srihari, Riya, tell me. The answer is no. The answer is no. Why? Because heat is not an absolute, okay, it's not an absolute term, it is a relative term, okay. Now, I can say that if the energy is exchanged between object 1 and object 2, right, if the energy which is exchanged, suppose 25 joule, okay, then I can say that the heat is 25 joule. The heat energy is 25 joule. Got it? Tell me, got it? Yes or no? Tell me, yes or no? Right? Right, everyone? Tell me, right? Yes or no? Please respond. Can you hear me? All of you can hear me? Because I'm not getting. Okay, so this is the first concept. When you talk about heat, it is not the absolute value, it is the relative value, or basically it is the energy change, right, between system and surrounding that we have already studied in chemistry. So I'll just revising. Okay, now when we talk about the measurement, how this is measured, tell me how this energy is measured. Now this energy is measured by a, tell me, parameter called as temperature. Okay, so for us, according to us, I can say that, okay, temperature is what? Temperature is degree of hotness or coldness, right? But we have already studied in chemistry, in thermodynamics, that temperature is measure of kinetic energy, right? Yes or no? Of the molecules, right? Got it? So temperature is basically a parameter which measures the degree of hotness and coldness of an object. Okay, got it? For this topic, we'll be considering that definition only. So I can say that, okay, if temperature of some object is more, if temperature is object 1, right, is more, right? This is suppose T1, and temperature of object 2, T2 is less, means T1 is greater than T2, suppose, right? I can say that the object having temperature T1 will be at higher energy, yes or no? Yes or no? Right? And the object having temperature T2 will be at lower energy. So heat transfer will take place. Okay, the heat will, tell me, transfer will take place from temperature, higher temperature to lower temperature. Makes sense? Tell me, makes sense? So these are very basic that we already know. I'm just trying to revise those simple concepts. I hope all of you already remember and know these concepts, right? Okay. So let's talk about calorimetry. So this was the basic introduction. Okay, basic introduction. Let's talk about calorimetry. What is calorimetry? What is the meaning of heat transfer and all those things? Okay, now think about it. Think about it. Okay, so this is something that we have already studied. Tell me, what is heat? Heat is the energy which is transferred between two bodies. Heat is the energy which is transferred between two bodies. Make sense? Right? Make sense? Wait, I'll just make the screen bigger. Wait. Okay. Is it better now? Tell me, is it better? Okay. Very good. Now, when we talk about heat, obviously it is a form of energy. So if it's a form of energy, it will have unit same as energy, which is joule. Okay. But there's one more unit that we use, that we commonly use. It is your calorie. Okay. And 1 calorie is equal to 4.18, or basically I'll be using, or we'll be using 4.2 joules. 4.2 joules. Okay. Right. Now think about it. Think about it. We know that it is a kind of energy. So I can say that energy can be transferred from one form to another form. Yes or no? Tell me, yes or no? Right? We know that energy is basically conserved, which means it can neither be destroyed nor be created. It can only convert from one form to another. Yes or no? Right? Suppose we rub our hand. Suppose we rub our hand. What will feel? Tell me, what we will feel? Suppose you are rubbing your hand. What you are feeling? Right? Especially in uh, chilly days, we try to rub our hand, right? Why we do that? Tell me why we do that? To warm up our hands. Yes or no? To warm up our hands. Yes, right? But what you're doing, you're actually rubbing your hand, which is your mechanical work. Yes or no? Yes or no? That is your mechanical work, right? Yes. So mechanical work is converted into heat energy, right? So I can say that, okay, the amount of mechanical work which is being done while rubbing is converted into the heat energy, right? Yes. Means there must be the mechanical equivalent of heat. There must be mechanical equivalent of heat, right? For conversion of that kind of work done into energy. Yes or no? Tell me, yes or no? Think about it. Yes or no? Right? So we have a term called as J, and J is called as mechanical equivalent of heat. Okay, J is called as mechanical equivalent of heat, right? Okay, which is basically joule per calorie, as simple as that. That's just a term that we have to remember, because sometimes instead of giving you actual work done, you'll be given mechanical equivalent of heat. Okay, right? If you remember, we had a problem like this. I told you that we'll be covering this term in next chapter. So when you talk about mechanical equivalent of heat, it is basically the work done per unit calorie, okay? Or it is the work done required to raise the temperature of 1 gram of water or 1 gram of any substance by 1 degree centigrade. Got it? Tell me, got it? Right? Now think about it. Try to solve this first example. Try to solve this first example. It will give you a clear picture. So Harsh, my voice is not clear. Everyone, my voice is clear. I'm trying to speak slow. So Harsh, my voice is clear for everyone. Okay, my voice is clear and I'm not speaking fast. My speed is fine, right? Everyone, tell me my speed is fine. Okay. Now think about it. Think about it. The question here is, what is the change in potential energy in calories, right, of 10 kg mass after 10-meter fall? So we know that. What is the work done in this case? Tell me, what is the work done in this case? mgh. And what is mgh? It is 10 into 10 into 10,000 joule, right? Yes, which is equal to change in potential energy. Got it? Right? Easy? Easy? Got it? Easy? Okay. Now, so this is in terms of mechanical work. Okay, but when you talk about thermodynamics, when you talk about calorimetry, okay, we use another specific term which is called as specific heat, right? Or just heat capacity. Yes or no? Tell me. I hope all of you remember specific heat capacity and heat capacity, right? So don't you think that, okay, this is something similar to mechanical equivalent, something similar to mechanical equivalent, right? Okay, so the next term that we will be studying is specific heat. Now, when you talk about specific heat, specific heat is basically the amount of heat required, right? Amount of heat required or released, okay, when 1 gram of any substance, 1 gram of any substance, okay, 1 gram of any substance is, tell me, raised to 1 degree centigrade. Okay, got it? So I can say that. Now think about it. Think about it, right? Suppose, everyone think about it. Suppose you have 5 kg. Okay, instead of using 5 kg, I'm saying 5 liter of water. Suppose you have 5 liter of water, and suppose you have 2 liter of water, right? Now, what do you think? In which case you have to supply more energy to raise the temperature by 1 degree centigrade? Tell me. Yes, very good. So this is without saying that 5 liter. Okay, so I can say that, okay, the heat supplied, right, will be more than 5 liters. So I can say delta Q is directly proportional to mass. Okay, that's first case. Now, second case, suppose I'm having 5 liter in both the cases. Suppose I'm having 5 liter in both the cases. But in one case, you are trying to increase the temperature by 1 degree centigrade. In another case, you try to increase by 2 degree centigrade. Now tell me, in which case, right, both of them, right, in which case, among both of them, we will require more heat. Second case, right? Yes, very good. So I can say that, okay, so this delta Q is also directly proportional to change in temperature. Yes or no? Yes or no? Right? So can I say that, okay, if this is something, if this is like, can I say that, okay, delta Q is directly proportional to M and delta Q is directly proportional to delta T. So can I write like this, delta Q is equal to M into delta T? Yes or no? Think about it. Yes or no? Tell me. Now, if you say yes, which means you are saying that doesn't matter whatever the liquid is it water or oil or milk, right? Whatever you take, if you are taking 1 kg of water, 1 kg of oil, 1 liter of water, 1 liter of oil, or 1 kg of milk, right? The temperature will be same, but obviously that won't happen, right? That won't happen. So there must be one under the term. So this is incomplete, okay? Because all these materials are different. Yes, very good. So we will include one term, which is S, right? M into delta T. So I can say that, okay, this S is depending on the material. Yes or no? Tell me, yes or no? Anyone have any issue in this? Tell me, anyone have any issue in this? No? Now, if you see this, I can say that, okay, S is equal to what? S is equal to delta Q by M into delta T, right? S is equal to delta Q by M into delta T. S is just a constant which depends on material, okay? So what is, according to this, what can be the definition of S? Can I say that, okay, it is the amount of heat required, right? If you make M is equal to 1 gram and delta T is equal to 1 degree centigrade, right? Then what you will say? I can say that, okay, S is equal to delta Q. Yes or no? Tell me, yes or no? If mass is 1 gram and change temperature is 1 degree centigrade, then S is equal to delta Q, right? So can I say that, okay, it is the amount of heat required to raise 1 gram of any substance by 1 degree centigrade, okay? Or you can take it as 1 kg also. Then it will be 1 kg of any substance by 1 degree centigrade. Make sense? Tell me, make sense, right? Got it? Yes or no? So I can say that it is the amount of heat gain or lost to raise or fall its temperature by, or to change the temperature by 1 degree centigrade for unit mass of the substance. Okay, got it? Tell me, got it? So S is M into delta S is equal to Q by M into delta T. Makes sense? Okay. Now, the value of S is constant. Doesn't matter whatever liquid you take, it is constant for different liquids because this depends on the nature of liquid, right? Now, when you talk about water, it is 4200 joule per kg centigrade, right? Or 1000 calorie per kg centigrade. Got it? Right? Now, specific heat of steam is equal to half of the specific heat of water is equal to specific heat of ice. Now, this is specific heat. This is not latent heat. Okay. Okay. Now try to find this. Try to solve example 2. Everyone try to solve example 2. Let's calculate once again. Yes, Abhiram, correct. See, it is 1 kg. Now 1 in kg into 20 is simple formula putting getting. So this is your 20 kilocalorie. Got it? 20 kilocalorie. Now this is specific heat capacity. Specific heat capacity because we are talking about 1 kg or 1 gram or unit mass of substance. Now suppose, right? You don't have to worry about the mass. Suppose you don't have to worry about the mass. Okay, right? I'm saying, okay, I'm providing X amount of heat and doesn't matter whatever the mass is, okay? Okay, yeah, was then it's correct. Sorry, kilojoule then it's correct. Sorry, I didn't see that, okay? Now, specific heat, if you think about it, specific heat is heat by mass into delta T, means for unit mass, yes or no? Yes or no, right? But suppose instead of unit mass, if I'm taking this m into s is equal to delta q by delta t, right? So which means that doesn't matter whatever mass you are taking, the amount of heat required to raise the temperature by 1 degree centigrade is this term, yes or no, is this term. And this term is called as heat capacity, just heat capacity, not specific heat. It is just called as heat capacity or thermal capacity, right? Got it, right? In chemistry, this is written as C, okay? So think about it. So heat capacity. So I can say that heat capacity is basically the amount of heat required to raise the temperature of any substance by 1 degree centigrade. Okay, right? So this is m into s. M into s. Now, if you remember, specific heat capacity is intensive or extensive. Tell me, specific heat capacity is intensive property or extensive property? Specific heat capacity, OS. Specific heat capacity. Intensive, right? Intensive, independent. Remember like that, right? And what about heat capacity? Heat capacity is depending on mass. So it is extensive, okay? Right? So I hope all of you understood these things. I hope all of you understood these things. Yes or no? Yes or no? Okay, right? Now, what is the meaning of water equivalent? The meaning of water equivalent is basically the mass of water. Suppose I'm giving you 100 joule of energy. Suppose I'm giving you 100 joule of energy, okay, right? Samya, I'll give you, don't worry, I'll explain, right? Now, suppose I'm giving you 100 joule of energy, okay, and I'm saying that this 100 joule is required to raise the temperature of, tell me, to raise the temperature of water by some temperature and to raise the temperature of, suppose, some other object, right? Oil, okay, by some, tell me, by some degree, okay, right? Now if I say that, okay, the change in temperature is same, suppose the change in temperature is same, so can I say that if I'm giving equal amount of energy, I can say that, okay, ms delta t is equal to m water delta t, right? Right? Yes or no? So mass of water, we calculate, right? Mass of water is what? Ms by SW. And SW is 1. SW is 1. Specific heat of water is 1, right? Because it is 1000 per kg. When you talk about per gram, it is 1. It is per gram, it is 1. Okay. So I can start, okay, MW is what? MW is water equivalent of this. So don't you think that MW is equal to heat capacity, or water equivalent is similar to heat capacity? Yes or no? Tell me. Yes or no? Don't you think that water equivalent is nothing but different term for? Yes or no? Got it? Tell me. Yes or no? So what is Water equivalent, it is basically the other name for heat capacity. Okay, got it everyone? Tell me, got it? Anyone have any issue in this? Anyone have any issue in this? No? Okay. So this is the amount of heat transferred when the temperature is changed. Yes or no? Yes or no? Right? What about the heat transfer when temperature change is not there? Right? Suppose an object is not changing its temperature, right? Temperature is not changed. So there won't be any heat transfer. Is there any case in which heat transfer can take place? Tell me. There's a case, right? There's a case, because when you talk about one special case, which is a phase change, we know that when you talk about phase, we have three different phases: solid, liquid, gas. Yes or no? Yes or no? So can I say that, okay, all the three phases will have, okay, all the three phases will have same energy? Tell me. Yes, Jitendra, I told you temperature change is same. That's why it will cancel, right? Same temperature is there. That's why I said it is same as heat capacity. Okay, now when you talk about the energy, I can say that the energy of all the three phases will not same, right? Because when you talk about intermolecular forces, it is highest in air, then in liquid, right? Sorry, it's highest in solid, then liquid, then air, right? Intermolecular forces. Okay, intermolecular distance is highest in air. Makes sense, right? Got it? So I can say that even though there's difference in energy, so if one object is changing from one phase to another phase, there must be change in energy. Yes or no? Tell me. There must be change in energy, right? There must be release of heat, right? Yes or no? Tell me, yes or no? Yes, and that is called your latent heat. That is called your latent heat, right? Because temperature change is not there now. So I can say that since temperature change is not there, since temperature change is not there, right? What I can say? Tell me what I can say. Think about it. If I'm changing 1 kg of ice, 1 kg of ice into water, right? And 2 kg of ice into water, will there be same energy change? Tell me, will there be same energy change? Yes or no? No, right? Clearly, no, because if it's 2 kg, the energy will be more in this case. So I can say that, okay, in this case, delta Q is directly proportional to mass. Now, second thing is, if it's changing from ice to water and then water to vapor, obviously the heat will be different. So it means there's another parameter which depends on the phase of transformation, and that is called as L, which is latent heat. Okay, energy. Makes sense? Tell me, makes sense? So delta Q is equal to ml. Delta Q is equal to ml is the latent heat energy when any object is changed from one phase to another phase. Makes sense? Tell me, makes sense? And this is a constant for given substance. So what is latent heat? It is the heat supplied to the substance which changes state at a temperature. It's called latent heat of the body, right? Okay. Now, latent heat of fusion is basically the amount of energy released or absorbed at the point of melting, which is conversion of, tell me, ice to water or water to ice. Got it? Same with latent heat of vaporization, when an object, right, or any substance is converting its phase from liquid to gas or gas to liquid. Now, we have to remember the value. When you talk about latent heat of ice, it is 80 calorie per gram. Okay, 80 calorie per gram, and latent heat of steam is 540 calorie per gram. So this is something that we have to remember. Now, if you see this phase curve, I hope all of you can understand this, right? So this is your absolute zero. Suppose this is your absolute zero. Okay, got it? Now, we know that suppose if temperature is increasing, right? So till some temperature, I'm talking about water. This is water, okay? This is totally water. I can say that, okay, till it reaches to a certain point, which is 0 degree in this case, it will remain ice, yes or no? Tell me, it will remain in ice phase, yes or no? Or solid phase? Yes, but temperature will change now, minus 30, minus 20, minus 10, temperature will change and it will increase. The temperature will increase as you give heat up to this point. Now, suppose you reach 0 degree centigrade. Suppose you reach 0 degree centigrade, right? Then you have to give some amount of energy for phase change. So there's no increase in temperature, but energy is required. So this is phase change, and this phase is what? Tell me. A is completely ice and B is completely water. So what is the phase between A and B? Tell me. What will be the phase between A and B? Tell me. Mix of ice and water. Yes or no? Yes or no? Yes, very good. Now, again, from B to C, water, it will increase till boiling point. This is your boiling point. Okay, boiling point. Now, at this point, it is totally water at 100 degrees centigrade. At D, it is vapor at 100 degrees centigrade. Vapor at 100 degrees centigrade. So I can say that between C and D, if you take any point between C and D, it is a mixture of vapor and, tell me, mixture of vapor and water. Okay, got it? So this is the phase diagram or energy change with respect to temperature, temperature with respect to energy. Okay, in case of water. Makes sense? Tell me, makes sense? Yes or no? Easy, right? Easy. Anyone have any issue in this? Tell me, anyone have any issue in this? Think about it. No? Okay. Now, one more thing that we know, that energy is conserved. Yes or no? The energy is always conserved. Makes sense, right? So we'll be using this concept and energy conservation concept to solve our problems. Now, suppose we have a problem like this. Think about it. Suppose we have a problem, right? See, we have a problem over here, which is find the amount of heat released if 1 kg of steam at 200 degrees centigrade is converted into minus 20 degrees centigrade of ice. Tell me, calculate this one, guys. Calculate. I'll give you 2 minutes. Calculate this, okay? Sorry, guys, I was mute. Thank you, Shamya. So I was saying, okay, that first ice at minus 20 degrees centigrade will convert to ice at 0 degrees centigrade. Okay, right? Then ice at 0 degrees centigrade will convert to water at 0 degrees centigrade. Okay, then water at 0 degrees centigrade will convert to water at 100 degrees centigrade. Okay, then water at 100 degrees centigrade will convert to steam at 100 degrees centigrade. Then this steam at 100 degrees centigrade will convert to steam at 200 degrees centigrade. Yes or no? Tell me. Yes or no? So if you see, just try to solve step by step. How many steps is involved? So we have Q1 over here, Q2 over here, Q3 over here, Q4 over here, and Q5 over here. This is same as this curve, right? This is same as this curve. OA is Q1, AB is Q2, BC is Q3, CD is Q4, right? And this is Q5. My bad. This is Q5. And D is Q5. Okay, right? So can I say that Q1 is what? MS delta T. Q1 is MS delta T. Q2 ML1, Q3 MS2 delta T, right? Then Q4 ML again, then MS delta T again, right? So if you think about it, don't you think that the answer would be fairly easy and simple? Tell me yes or no. Yes or no? Got this concept, everyone? Got this concept? Tell me yes or no. Easy? Finding this easy? Okay. Now think about it. Suppose this amount of heat is released by this 1 kg, right? So there must be something which will gain it now. Either atmosphere or some other object. Yes or no? Tell me yes or no. Because we know that heat can never be lost. It can always change its shape, right? So not shape, okay, right? One form to another form, its form. Makes sense? So I can say that, okay. If heat is gained, heat if is lost by this, then the same amount of heat should be gained by something. Yes or no? Means I can say that if I'm having two objects, okay, and if one object is losing heat, right, which is delta Q1, it is heat lost, right? Then the heat gained by the second object should be equal to this. Tell me, this delta Q2 should be equal to delta Q1. Make sense? Tell me yes or no. Yes or no. Got it? And that is the basic or fundamental idea about calorimetry. Okay, so basically calorimetry is branch of thermodynamics which deal with measurement of heat. That's it, right? And this is a law of mixture. Law of mixture says that whenever two or more substance is mixed, okay, whenever two or more substance is mixed, I can say that the heat gained by one is equal to the heat lost by the second one, right? Right? So heat taken by one substance is equal to heat given by the substance. This is based on conservation of energy. Yes or no? Tell me yes or no. This is based on conservation of energy, right? For example, if I'm having same example, if I'm having a coffee, at suppose 80 degrees centigrade, okay, coffee at 80 degrees centigrade, right? And suppose a mass of coffee is given, suppose it is 100 grams. I'll be taking every unit of mass in grams, okay, right? Now suppose you take one ice cube at -5 degrees centigrade and drop it in this coffee, and the weight of this is suppose 10 grams, right? So what do you think? What will happen? Tell me, what will happen? Tell me. I can say that, okay, the temperature of coffee will decrease. Right? But the temperature of ice will increase, right? Okay. Yes, cold coffee. Okay. So I can say that the amount of heat lost by coffee should be equal to amount of heat gained by ice. Yes or no? Tell me yes or no. Right? Got it? Okay. So I hope all of you understood this. Tell me. I hope all of you understood this. So try solving this problem. Guys, try solving this problem. Try solving this problem. It's easy one. So see, I can say that here an iron block of mass 2 kg. Think about it. An iron mask, sorry, mass, not mask. Okay, 2 kg fall from height 10 meter. Okay. So obviously it will be changing potential energy. And after colliding with, yes, very good, Ria. Ovais, it's almost close. Okay. Right. After colliding with ground, it loses 25% energy. So obviously it will be 1 by 4 mgh. And this change in energy should be converted in what? Tell me. Rise in temperature of the block. So it is same as mechanical equivalent of heat or just heat, right? Heat gained by this block is equal to the change in potential energy of the block, right? Right? So delta T is this. So if we calculate, it is almost 0.15. Okay, almost, right? Okay. Now, I hope all of you remember zeroth law of thermodynamics. Yes or no? Right? What happened? That is an issue with PDF. Wait. Yeah. So I hope all of you remember zeroth law of thermodynamics. Tell me yes or no. Right? Yes, everyone remember that whenever we have two or more objects, if A is in equilibrium with B and B is in equilibrium with C, right, then A should be in equilibrium with C, right? That is one statement. Okay, and basically we will be using the concept in calorimetry. Now, try to solve this problem. Try to solve this problem. Everyone, try to solve question number 5. Everyone, try to solve question number 5. The temperature of equal masses of three different liquid A, B, and C are 10 degrees centigrade, 15 degrees centigrade, and 20 degrees centigrade, right? Okay, respectively. The temperature when A and B are mixed is 13 degrees centigrade. And when B and C are mixed, it is 16 degrees centigrade. What will be the temperature when A and C are mixed? Okay, what's the temperature when A and C are mixed? Try to solve this. Everyone, please try to solve this. Take 2 minutes. When we solve this problem, okay, right, try to start with basic concept. When you try to solve this problem, we have three different liquids, A, B, and C. Yes or no? A, B, and C, right? Now, I can easily say that temperature will not be, okay, temperature will not be, right, less than 13 degrees centigrade or more than 16 degrees centigrade. Yes or no? Tell me, yes or no? So it is said that when A and B is mixed, okay, when A and B is mixed, right, is 13 degrees centigrade. And when B and C is mixed, then it is 16 degrees centigrade. So obviously, right, obviously if A and C will mixed, the temperatures must be somewhere between 13 and 16, now, like using just your normal concept. Yes or no? Tell me. Think about it. Your intuition. Think about it. Yes or no? Right? Yes. So when A and B are mixed, the final temperature is given as 13. So I can find the relationship between S1 and S2, yes or no? Because delta T is given, mass is equal, S1, S2 relationship I can find. In the same way, when B and C is mixed, then I can find the relationship between S2 and S3, right? and equating this and this, I can find the relationship between S1 and S3. Okay, right? Got it? Then it is easy. Yes or no? Tell me, everyone got this? Yes or no? Yes, got it? Easy? Now I hope all of you got the concept. Try solving one more problem. Try solving one more problem. Now just go through it. This is quite easy. Just go through it. Okay, just go through it. I won't be asking you to solve it. Just go through it. Right? If three liquids of different masses, right, and specific heat capacity are all mixed. Think about it. Are all mixed, right? So if all are mixed, what do you think? Tell me. Net sum should be zero, yes or no? Tell me. Yes or no? Net sum of heat should be zero because someone will be gaining, someone will be losing. That's first concept, yes or no? Right? And the final temperature should also be same. The final temperature should also be same because all the three are mixed together, right? So this is the concept that we have to use, as simple as that. Okay, got it? So the final temperature will be given by, right, M1 S1 T1, M2 S2 T2, M3 S3 T3 by M1 S1 plus M2 S2 plus M3 S3. This is the basic concept. You don't have to remember the formula, right? But this is the basic concept. Okay, right? You can use this for 2 liquid, 3 liquid, 4 liquid, and this is comparatively easier to use. Now, next problem, try to solve this. Try to solve this problem. Think about it. Tell me. Okay, so you just have to put the value, yes or no. Tell me, yes or no. Yes, yes, very good. So the answer is, tell me. So in this, right, you have to find the value of H 1 kg of ice at minus 20 centigrade, right, which is, and H plus 1 kg is equal to H plus 1 kg of water at 100 centigrade, which means heat required to change the state of substance. Okay, so just put it, you will get the answer as, tell me, minus 190 kilocalorie. Yes or no? Tell me, yes or no? Because you have to convert 1 kg of ice, just take that now, 1 kg of ice, okay, into, tell me, 1 kg of water, as simple as that. So this is something that we have already calculated. Okay, so question number 8 is also like that. Question number 8 is also like that. I'll share this. Try to solve question number 8 also. Okay, got it? Anyone have any issue in calorimetry? Tell me. Anyone have any issue in these concepts? Heat gain is equal to heat lost? Or it is clear? Tell me. Is it clear? Or you have any doubts? This is first part of calorimetry, right? See, the problems is based on heat gain is equal to heat loss. So you have to solve multiple problems. Okay, so go through all the examples. Okay, very good. Very good, everyone. So I hope all of you, right, all of you understood this first concept, which is calorimetry. Now, when you talk about the second concept, think about it, right? Think about it. What will happen? What will happen if you increase the temperature of any substance. Think about it. What will happen? What might happen? Think. Can't hear you. Everyone can hear me. Right, everyone? All of you can hear me, right? Yes. Okay, everyone can hear me? Okay. Yeah, think about it. Okay, think about it. If I'm saying, if I'm heating something, if I'm heating an object, right? We know that the basic definition of temperature is what? Increase in its kinetic energy of the molecule? Yes or no? Increase in kinetic energy of the molecule, right? Now, if the kinetic energy of molecule will increase, then what will happen? What do you think? What will happen? If the kinetic energy of a molecule is increasing, then what will happen? The molecule will move faster, yes or no? The molecule will move faster. Make sense? Right? And if it yes, so if it moves faster, right, then it will try to occupy more space. Yes or no? Right? So there's a phenomena associated with that, and that phenomena is called as expansion. Okay, that phenomena is called as expansion. Got it? Tell me, got it? Right? So I can say that whenever we talk about any object, if the energy is changed, right? If energy is supplied or taken out, which results in the change in the interatomic distance. Yes or no? Yes or no? Right? Which in turn, right, can affect their length, volume, area, and so on. Got it? Tell me, got it? I hope all of you understood this concept. Yes? Yes? Yes or no? Tell me. Now try to see this problem. Everyone try to see this problem. Okay, we have a small problem where some small conceptual problem, right? Think about it. Can you see this problem? Tell me, can you see problem number 9? So what is the problem? We have a rectangular plate and it is having a circular cavity. Okay, at the middle we have a circular cavity, and the problem is if you increase the temperature, okay, right? If you increase the temperature, then which dimension will increase? We have A, B, C, and D. Tell me, which will increase? A is length of the rectangle, B is the breadth of the rectangle, C is the diameter of the circle, right? And D is the distance between the circle and the length. Okay, Abhiram, it's conceptual. Yeah? It has nothing to do with your numerical aspect, right? It's just conceptual. Okay. Yes, very good. So the actual answer should be what? Tell me, think about it. Think about it. The actual answer should be what? All the dimensions, right? All the dimensions should increase now. Yes or no? Yes or no? Because when you are heating, when you are increasing temperature, right, the intermolecular distance between the atoms will increase, right? And obviously, if any 2 points will move or any 2 point will expand in similar way, then obviously I can say that all the 4 parameters will increase. Got it? Tell me, got it? Yes or no? Right? I hope all of you understood the problem. Question number 9 and 10. Okay? 9 and 10. Easy? Yes or no? Tell me, yes or no? Got this concept? Tell me guys, got this concept? Akshaya, got it? Angha, Chulika, Soumya, Jasharan, Koshi, Mansi. Okay, very good. Now next. Now when we talk about expansion, I can say that okay, expansion can occur, right, in all the three dimensions, either one dimension or two dimension or three dimension. So whenever we talk about expansion, we'll start with one dimension. If the expansion is occurring in only one dimension, which means either length or breadth or height, right? Just one dimension. So I'll just say that it is your linear expansion. Yes or no? It is your linear expansion. And the formula is given by, now think about it. If you want to think, right? Think about it. Instead of just trying to remember the formula, just try to think about the formula. Okay. Yes, that's why most of the concept will be mixed. Yes, most of the concept will be mixed. Now, if I want to heat this rod, suppose I'm heating this, increase in length, there will be change in length. Yes or no? Now, I want to find on what are the factors that this change will depend, right? So I can say that, okay, this will depend on change in temperature. Yes or no? If you heat more, it will expand more, right? If you heat more, it will expand more. Got it? Right? Then second thing, okay, now if I say that if I'm taking one longer length, right, and then second rod with shorter length, so I can say, okay, the rod with longer length will elongate more. Yes, so it will depend on length also. Now, what are the third factor? Third thing is, now it's not the factor. Basically, third is the property of the rod, right? Be it your steel rod or copper rod or aluminum rod. I cannot say that all the three rods will expand in the same manner. Yes or no? Tell me, right? Can I say that all the three rods will expand in the same fashion? Tell me. Wes, Samya? No, right? I cannot say that because all the three rods will have different properties. They are different. They're made of a different material. Okay. So when you when you include these two, right? I can say okay, delta L should be equal to what? Alpha into length into delta T, right? Yes or no? Tell me yes or no. And what is delta L? Delta L is final length minus initial length, or I'll write it as L naught. Initial length, which is equal to alpha delta T, alpha into L naught into delta T. So can I say that, okay, I can say that L2 is equal to L naught. We'll take this to that side. We'll take bracket 1 plus alpha delta T. Yes or no? Tell me yes or no. Yes or no? Easy? This is easy topic. This is always easy topic. I hope all of you understood this concept. Right? Okay. Now, this is when your alpha is constant. Alpha is not variable. But suppose alpha is also a variable. If alpha vary with respect to length, right? So you cannot just use this formula. You have to use integration, and the relationship will be this. Got it? Tell me, got it? Right? But if alpha varies with temperature, then this. Yes, alpha. Alpha is called, alpha is a constant, right? Alpha is called as linear coefficient of expansion. Alpha is a constant which depends on material, right? Okay. Usually, I'm talking about the usual problem, right? But obviously, when they want to transform, or when they want to form a problem, they can give alpha as a variable, right? For numerical type of problems. Okay. Got it? Right? Anyone else? No? Okay. Okay. People are leaving. So I'll teach whole concept. There are around 7 students who left already. Sneha, you are here. Sneha is also absent, I guess. So I'll mark all those students who left the class, because I'll just take the attendance at the last of the classroom. Okay. Right. I'll take the attendance at the end of the classroom. Okay. So I hope all of you understood this concept. Now, if I want to solve a problem, like think about it. Now, these concepts will be used, okay, these concepts will be used with, tell me, the concepts of stress and strain. I hope all of you remember delta L by L, right, is equal to alpha delta T. So this will be used along with the concepts of stress and strain. Otherwise, there are some cases, right? There might be some cases in which it depends on temperature, because whenever we talk about alpha, we take it as positive, but we know that for semiconductor it is negative. Sorry, it's not this. Sorry, not this. It is for rubber. Okay, sorry, right? So we usually assume that whenever we talk about change in length, right, it will be positive when temperature increase. But there are some substance which will, tell me, decrease, which will not expand it, they'll contract if temperature is increased. So that's totally different factor. Okay. Now try to solve question number 11. Try to solve question number 11. I hope all of you can solve question number 11, right? Percentage change in length. So you have to find delta L by L, which is alpha delta T. So that you will solve. Now thermal stress. So thermal stress is stress due to change in length, right? Due to change in length, right? Due to temperature change. So that is your basic formula, okay, which is Y into strain, and strain is delta L by L, and delta L is alpha delta T into L. LL will get cancelled, so we will get strain as alpha delta T, alpha delta T. And we know that stress is equal to what? Stress is equal to Y into strain. So it is Y into alpha delta T. Make sense? Tell me, make sense? Yes or no? Yes or no? Easy? If you remember the concept, it is easy. So usually we remember like this. Usually we remember like this. Okay. So if you talk about the actual definition, then it will be this, right? Delta L by L at that temperature, which is L naught 1 plus alpha delta T. But this is very less as compared to 1. That's why it will be ignored, and we'll take just normal temperature. So can you solve this problem? Tell me, can you solve this problem? Can you solve this problem? Question number 12. The option is given, right? It should not take more than 5 seconds. It should not take more than 5 seconds. What's the answer? Tell me, what do you think? What's the answer? Yes, very good. The answer is no, Nishita. Think about it now. First of all, it is, my question is, can this rod expand? Tell me, can this rod expand? Yes or no? it can expand. No, it is not fixed. Think about it, right? It is not fixed from the both ends. Yes or no? It is not fixed from the both end, right? So it can expand. So there's no restoring force in this. Agree, there's no restoring force now. Think about it. Because when you talk about this case, right, it was closed at both the ends. That's why when it want to expand, right, there will be restoring force because of the wall. Got it? So in this case, the answer will be zero. The answer will be zero because it can expand freely. Okay, got it? Right? So question number 13 also you can solve, 14, 15, all based on this. Okay, now on what factor, right? I hope all of you can solve all these examples. And the next concept is what? Yes. So I can say that when you talk about the time period, okay, time period, I can say the time period, this is the concept that we'll be covering in next chapter. But again, I'll just let you know what is the formula. Okay. When you talk about the time period is given by 2 pi root L by G. 2 pi root L by G. Think about it. Okay. Now, since this time period is directly proportional to root L, right? If this L is changed due to any way, right? Any way, be it temperature or stress or strain, doesn't matter, right? There will be change in time period, yes or no? Yes or no? Tell me. Got it? Yes. So what do you think? If you increase the temperature, if you increase the temperature, or during summers, this length will increase, yes or no? Tell me. This length will increase. What will happen to time period? It will increase or decrease? It will increase or decrease? Tell me, increase or decrease? Guys, reply. Time period will increase, not time period will increase, which means it will take more time to, right, complete 1 hour. It will take more time, right? Okay, it will take more time to show 1 hour, right? So what do you think? Clock will become fast or slow? Tell me. Clock will become fast or slow? Slow. Very good, Samya. Got it? Right? Got it? So if someone asks you during summer season, if the clock becomes slow, then what is the reason? You can answer this, right? So this is the formula. Based on this, you can just use the concept or the ratio as 1 plus 1 by 2 alpha delta t. Okay, why this is 1 by 2 alpha delta t? Tell me. That is the approximation of binomial. If you remember, this is the approximation of binomial. 1 plus alpha delta t or delta theta to power 1 by 2, right? Got it? Okay, so you can just remember this. Okay, so this is about linear expansion. This is about linear expansion. Okay, right? Got it? Tell me. So in next class, we will continue with expansion there, because when you talk about linear expansion, there are lots of concepts which will be covered in this. For example, think about it. There's bimetallic strip. Okay, then there's expansion of different containers, expansion of different uh, rods having different coefficient of expansion, right? Got it? Tell me. Okay. Now think about it, right? Before this, think about it. Suppose, right? Suppose you want to measure something. Suppose you want to measure something. Okay, right? So obviously, I can say, if the temperature is increased, the scale length will also change. Yes or no? Suppose the scale length will also change, and rod will, this length of the rod will also change. Yes or no? Yes or no? Right? So I can say that, okay, I can say that, let's take this case. Okay, now I can say we have different cases. We have first case when scale is not changed, when scale is fixed, right? Scale is not changing, only length is changing, right? So that's easy, right? That's quite easy. So I can find the change as alpha delta t. Makes sense, no issues, right? That's easy. Now second case is, right, the rod is not changing. The rod is not changing, okay, right? Think about it. Only the scale will change. Only the scale will change. Then I can say that, okay, in that case, the length of rod will be lesser. Yes or no? Tell me. Because if the scale will change, now this 3 will be here, right? Here. So if the rod will not expand, then it will be shorter as compared to the actual length, right? And third, if both will change, now if both will change, then the net change in length will be what? Tell me, the net change in length will be change in scale or change in rod, right? Minus change in scale, yes or no? Tell me, right? Delta L of, tell me, rod minus delta L of, tell me, scale. Now, since you have to consider the actual length to be same, now, because if it is 3, scale will also read 3 without expansion, right? So it will be what? 1, 1. Now, because the alphas are different, so it will be what? LL will get cancelled. LL will get cancelled. Okay, sorry, not cancelled, common. Minus, this will be alpha rod plus alpha rod minus alpha scale into delta T. Yes or no? Tell me, yes or no? Think about it, yes or no? Right? This is L2. Now, depending on this value, if this value is positive, then L2 is more than L. And if this is negative, then L2 is less than L. Right? Got it? Tell me, got it? Anyone have any issues in this? Anyone have any issue in this? Think about it. Anyone have any issue? Akshaya, Samya? Got it? Very good. Easy? This topic seems easy. So I'll share this, try to solve all the examples, okay? Try to solve all the examples and try to solve the examples of HC Verma, right? HC Verma, in HC Verma there's one chapter called Calorimetry, okay? Try to solve that chapter, okay? Of Calorimetry of HC Verma. Okay, everyone? Right? And please tell me your attendance, right? Please tell me your attendance. First, J students, okay? Akshay present, Jitendra present, Karishma present, Abhiram, Sai Smriti present, Sai Smriti is absent. Okay, Sai Smriti absent. Sai Smriti absent, Abhiram present, Mansi is absent. Mansi is absent. Mansi absent, right?
Present, sir.
Present,
Present,
okay.
sir.
Okay, Mansi present. I can't see Mansi over here though. Okay, Mansi is present, yes. Sai Smriti is absent. Okay. Samya present, Chulika present, Riya present, Koshi present, Sanya present, Sneha absent. Sneha absent. Aryan present. Aryan is absent, I guess. Aryan is absent. Nidhi present. Jasharan, Samarth present. Samarth is absent.
No, sir, present.
Present, okay. Then Anagha present. Pranjal, Pradyumna present. Pradyumna present. Pradyumna is absent.
Present, sir.
Present. Please respond, okay? Otherwise, you will be marked absent. Anurag absent. Anurag absent. Okay, Anurag absent. Then Krishna.
Present, sir.
Okay. Tulip. Tulip is okay. Tulip left in between, I guess. Tulip is absent. Okay. So J students, you can leave. J students, you can leave.